Good evening, students. Today we are continuing with mole concept exercise 5A numericals, that is from 16 to 21. Today in this lecture we will complete. Observe the question number 16. What volume of air containing 20% oxygen by volume is required to burn completely 10 centimeter cube of methane as well as acetylene? Fine. See, hope you have understood this. They have given the combustion equation for both methane as well as acetylene. Separately we will solve it. First and foremost thing is writing the volume here. We know that 1 volume of methane requires a 2 volume of oxygen, and here how much is given? 10 centimeter cube. So for this, what is required? How much of oxygen is required? Now take it as x and cross multiply. What you get? You get x is equal to 20 centimeter cube. So that means we require 20 centimeter cube volume of oxygen. Now there is the statement 20% of oxygen is present. Okay, 20% of oxygen by volume is present in air. So how much air is required? So that we can take it as 20%, that is 20 by 100 of x. Let us take x volume of oxygen is nothing but 20 centimeter cube of oxygen required. Hope you have understood this. We need 20 centimeter cube of oxygen. For that, how much air we have to take? We can take like this. So sending to the other side, we get x is equal to 20 into 100 by 20. 20 gets cancelled. Therefore, we can say that we need 100 centimeter cube of air for the combustion of methane. This is your part 1. Now coming to the second one, acetylene or ethane. 2 volume of acetylene requires 5 volume of oxygen. Given volume is 10 centimeter cube. Therefore, take it as x volume of oxygen in acetylene combustion. 2x is equal to 10 into 5. Therefore, x is equal to 10 into 5 by 2, nothing but 25 centimeter cube. So how much oxygen is required? In this case, we need 25 centimeter cube of oxygen. And it is given 20% of oxygen in air. Therefore, we know that 20 by 100, you can take it as x or by anything, is equal to 25 centimeter cube of oxygen. So this is for air you can take. So air is to be calculated in this method. Now send to the other side. X is equal to 25 into 20 by 100 will become 100 by 20. So cancel this. This will be 5. So we need 125 centimeter cube of air. So in the case of methane, we need 100 centimeter cube. In the case of acetylene, we need 125 centimeter cube. So therefore, finally, total volume of air required is nothing but, in the first case it is 100, in the second case it is 125. Therefore, 225 centimeter cube of air. So this is your final answer. Hope you have understood this. Very simple numerical here. Now let us move to question number 17. Next, question number 17. LPG, that is liquefied petroleum gas, has 60% propane C3H8 and 40% butane C4H10. They have taken 10 liters of this mixture and burnt. So the question is, what is the volume of CO2 which is added to the atmosphere? So this is first equation. Propane with oxygen gives 3 moles of CO2 or 3 volumes. Here it is 8 volumes. Now, what is the step 1 here? Step 1 is calculate how much quantity of propane is there and how much quantity of butane is there. Now, first one. Here we can take it as volume of propane. Volume of propane. They have mentioned that it is 60%. So 60% of 10 liters. Fine, so it is 60% of 10 liters. Second one is volume of butane. It is mentioned as 40%, so 40 by 100 of 10 liters. So let us calculate this. 60 by 100 into 10, we can cancel this. So we get 6 liters of propane. First one is 6 liters of propane. Now what is the second one? Butane. How to calculate? 40 by 100 into 10, nothing but 4 liters. Step 1, we have calculated the volume of propane as well as volume of butane. Now step 2, you can calculate. Step 2, we can calculate CO2 liberated in this case and CO2 liberated in the second case of combustion. Now we know that C3H8 is giving us 3 volumes of CO2. So we can write like this. One volume will give 3 volume of CO2. Now what is the quantity here? 6 liters. We can take it as X. On cross multiplication, what we get? X is equal to 6 into 3, nothing but 18 liters of CO2. In the first case, that is on combustion of propane, how much volume of CO2 is liberated? 18 liters. Now coming to the second point, here 2 volume of butane gives us 8 volume of CO2. So we can write like this. 2 volume gives 8 volumes of CO2. Now what is the quantity here? It is mentioned that 4 liters. Let us take it as X. On cross multiplication, 2x is equal to 8 into 4. X is equal to 8 into 4 by 2. Nothing but 16 liters of CO2. Hope you have understood this. Very simple. In the first case, 18 liters is liberated. In the second case, 16 liters is liberated. Now, total volume of CO2 that is added to atmosphere. Added to atmosphere. Add that, first one 18, second one is 16. So totally we get 34 liters of CO2. Hope you have understood this. A very simple question. So question number 17 is completed. Let us move to question number 18. Now read question number 18 and try to solve it. 200 centimeter cube of CO2 is collected at STP. That means they have mentioned that 4 volume of CO2. 4 volumes of CO2 is nothing but 200 centimeter cube. Is collected at STP when mixture of acetylene and oxygen is ignited. They are asking what is the volume of these two. So very simple. You are knowing here that 4 volume is equal to 200 centimeter cube. We can write like this. 4 volume of CO2 has the volume 200 centimeter cube. So you want to know about one volume. Therefore, one volume you can take it as X. On cross multiplication, what we get? 4x is equal to 200. X is equal to 200 by 4. Nothing but 50 centimeter cube. So finally what we got? We got that one volume of any substance here is equal to 50 centimeter cube. We got this. Now for acetylene, what will be your volume? You know that they have mentioned it as 2C2H2, therefore it is 2 volume. One volume is 50, 2 volume is equal to 2 into 50, nothing but 100 centimeter cube. So acetylene we got 100 centimeter cube. Next, for oxygen at STP 5O2, therefore 5 volume is nothing but 5 into each volume is 50, so we get 250 centimeter cube. So we find like this 100 centimeter cube of acetylene is there and 250 centimeter cube of oxygen is there. Hope you have understood this. Very simple. First and foremost thing is it is given that 4 volume of CO2 nothing but 200 centimeter cube. This is the only value what you are given with. So 4 volume is 200, therefore 1 volume if you calculate is 50. With this, you can easily identify 2 volume of acetylene is 100, 5 volume is 250 centimeter cube of oxygen. Hope you have understood this. Now let us move to question number 19. Now if you see question number 19, you have collected, see they have given 5 samples of gas. First one 2 liter carbon dioxide, 3 liter chlorine, 5 liter hydrogen, 4 liter nitrogen, 1 liter sulfur dioxide. They are asking under similar conditions of temperature and pressure, which will have greatest number of molecules and which will have least number of molecules. I have solved this here to save time. First one, see we all know that the standard volume 22.4 liters of any gas has Avogadro number, that is 6.023 into 10 to the power of 23 molecules. This is standard one which we are going to apply in all the 5 cases. Now what is given, volume is only 2 liters, so we can write like this: 22.4 liters of carbon dioxide has this number of molecules, so 2 liters can be taken as X, cross multiply, and you get 0.54 into 10 power 23 molecules of CO2. Next, 3 liters, again follow the same method. For a standard 22.4 liters of chlorine, you have Avogadro number of molecules, but instead of 22.4 they have given only 3 liters, so we take it as X, cross multiply, so X will be 0.8 into 10 to the power of 23 molecules of chlorine. Next, 5 liters hydrogen, apply the same method. 22.4 liters hydrogen has Avogadro number of molecules, 5 liter is taken as X, on cross multiplication we get 1.35 into 10 power 23 molecules of hydrogen. Now fourth one, 4 liter hydrogen. See this is nitrogen, 4 liters of nitrogen. Take the same thing, standard 22.4 liter has Avogadro number of molecules, but only 4 liter will have how much here? Again into 4 by 22.4, you get 1.075 into 10 to the power of 23. This is for nitrogen. Now the last one, 1 liter of SO2. Standard is 22.4 liter has Avogadro number of molecules, only 1 liter is taken as X, cross multiply, X will be 0.268 into 10 to the power of 23. So now, first one is carbon dioxide number of molecules, so we can write here number of molecules. Carbon dioxide 0.54 into 10 power 23, 10 to the power of 23 is common in all the case, so you can compare only this value. Second one is for chlorine, third one hydrogen, fourth one nitrogen, last one is sulfur dioxide. So if you compare 1.35 into 10 power 23 is the highest value, so which is having highest number here, that is by hydrogen, 5 liters of hydrogen. Next, least one is 0.268, so we can say that least one is nothing but which has least number of molecules, sulfur dioxide. So 1 liter SO2 will have least number of molecules and 5 liters of H2 has highest number of molecules. I'll keep the video on for 2 minutes so that you can copy the answer. Hope you have understood this. So we have completed almost all the numericals. So if you have any doubt, you can put in the comment section. Hope you have understood this. Thank you so much.